In this video, we're going to write the equation of a line in standard form. So far, we can write the equation of a line in two different forms. The first form that we started with is point-slope form. And remember, this is where we always start when we're writing the equation of a line. And this is the equation where we have y minus our y-coordinate is equal to m times in parentheses x minus our x-coordinate. So we need a point and a slope to write this equation of a line, and we always start here. Then from here, we know how to rewrite point-slope form into slope-intercept form. And we always start in point-slope, and then we rewrite it into slope-intercept form. And that's where we have y equals mx plus b, where our y value is alone. So what we're going to do today is we're going to learn about a third form of an equation of a line and talk about how we would write our equation of a line into that third form. So our third form of a line is called standard form. And a couple of key characteristics of standard form. I want you to first note that all of the variables, so we have our x's and our y's, our variables are together on one side of the equation. So you can see that on the left-hand side we have the coefficient of x times x plus the coefficient of y times y. So the variables are together on one side of the equation. On the other side of the equation, that constant value, so the number that has no variables, is all by itself. So in standard form, this is where we ultimately want to end up. We want to end up with the constant on one side of the equation by itself, and then we want all of the variables on the other side of the equation together. So in order to write the equation of a line into standard form, we're essentially going to take what we already know about writing the equation of lines and simply add one step to it. So what we're going to start with is we're still going to start in point-slope form. So what that means is we're going to need to find our slope and find a point if needed. So that's where we're going to start here. Then we're going to rewrite the equation into slope-intercept form. And then once we've done that, we're going to take one more step and we're finally going to rewrite it into standard form, which is when we get our constant alone. So notice how similar the steps are from writing the equation for a slope-intercept form equation or a point-slope form equation. So here to start, we're going to find our slope if it's needed, which we can see we have 2 points. So I have x1, y1, x2, y2, so I can see that, yes, in fact, I do need to locate my slope. So here I have m equals, I have y2 minus y1 over x2 minus x1. So a lot of negatives going on here. So from here I'm going to utilize keep, change, change, keep, change, change. Negative 6 plus 9 is 3. Negative 1 plus 2 is 1. So I have a slope of 3 over 1, or 3. Then from here, I'm going to start by writing the equation of my line into point-slope form. So we always start here in point-slope form once we have a point and a slope. We need to pick a point to use. I'm going to pick this first point here. Remember, it does not matter which point you pick. So I'm going to start by writing it into point-slope form. So I have y minus my y-coordinate, which is negative 9, is equal to my slope, which is 3, times x minus my x-coordinate, which is negative 2. Here I'm going to utilize keep, change, change, keep, change, change. So my point-slope form is y plus 9 is equal to 3 times x in parentheses plus 2. So here I have my point-slope form. Then what I'm going to do from here is I'm going to rewrite that equation into slope-intercept form. So I know that to start doing this, I need to distribute to get rid of those parentheses. So here I'm going to get y plus 9 is equal to 3x plus 6. And then in order to get it into slope-intercept form, I need y alone. So I'm going to subtract 9. So I have y is equal to 3x plus a negative 3. Then finally, to end, I want to end in standard form, which means my constant value with no variable is what I want by itself, which in this case is this negative 3. So there's no variable attached to it. I want to get it by itself. So essentially what we need to do is we need to undo this 3x here. And if we want to undo an entire term, we need to subtract it. So notice how these added together will become 0 from each side. Now remember, in standard form it goes ax plus by is equal to c. So we want our x's first, which in this case I can see I have a negative 3x plus my y's are second, which is just y, is equal to my constant term by itself, which is negative 3. So essentially we start just where we started before in step 1, finding the slope, work through point slope form, through slope intercept form, and then ultimately end in standard form. So same process here, just a slightly different look. We're going to write the equation of a line that goes through those points listed below into point slope, slope intercept, and standard form. So we're going to start by finding the slope, which we can do with that y2 minus y1 over x2 minus x1 equation. But because we have a graph here, we can actually utilize the rise over run, which is what I'm going to do. So here, to move from the point in red to the point in black, I need to vertically move in the negative direction 2. So I have negative 2 is my rise, and my run is a positive 3 in the x direction, so I have a positive 3. So my slope for this line is a negative 2 over 3. Then from here, what we need to do is we need to write the equation of a line into the 3 form. So we always start with point slope form. We need to pick a point, and then we have our slope. So I'm going to pick the point negative 4 comma 3. So here I have y minus my y coordinate of 3 is equal to my slope of negative 2/3 times x minus my x coordinate of negative 4. So I utilize keep, change there, and my final point slope form equation is y minus 3 is equal to negative 2/3 x plus 4 in parentheses. So this right here is our point slope form. Then we're going to move on and we're going to find our slope intercept form, which remember is when we have no parentheses and y is alone. So here I distribute the negative 2/3. So we have y minus 3 is equal to negative 2/3 x. And then we need to figure out what negative 2/3 times 4 is. So I do negative 2 over 3 times 4 over 1, which ends up being negative 8 over 3. So here we would do plus negative 8 over 3. Then from here I need to get y by itself to be in slope-intercept form. So I add 3 to each side. So I have y equals negative 2/3 x. And then I have negative 8/3 plus 3. So that could be 3 over 1. We need a common denominator. So that's really, if we multiply everything by 3, that's really 9 over 3. So that's negative 8/3 plus 9/3. So here we really have negative 2/3 x plus 1/3. So that is my slope intercept form. And then finally from here we want to end in standard form, which is when we have the constant, which here is 1/3, by itself. So we need to move that x term completely. So we're going to add 2/3 x, add 2/3 x. And so we ultimately end up with 2/3 x plus y is equal to 1/3 for our standard form. Remember here, our constant value is alone, and our x's and our y's are together on the other side of the equation. So standard form is actually really helpful for when we're dealing with a very specific type of word problem. And you're going to see that here in this example. So these are typically called cost word problems or cost equations. And you'll see why as we read through this together. So this example says you are at the grocery store and need to purchase fruit for your team breakfast. Apples cost $5 per bag, and mandarin oranges cost $6 per bag. Your mom gave you $90 to spend on fruit, and you intend to spend exactly $90. So, here we need to write an equation in standard form to represent the situation. Here we can see that we're calculating cost. Our cost, which I'm going to write out, is calculated by taking the number of bags of apples times the price of apples added together with the number of bags of the oranges times the price per bag of oranges. So that's really how we calculate our cost in this situation. Now let's fill in some of those pieces that we know. The first thing we know is we know that our cost is going to be exactly $90. So we can substitute the 90 in for our cost. We then don't know how many bags of apples we buy. So here I'm going to represent bags of apples with X because it's an unknown. Times our price, which is $5 a bag, plus the number of bags of oranges, which in this case I'm just going to call it Y, it's another unknown value, times the price of oranges per bag, which is 6. So you can see here you take your cost and it's calculated by number of bags of apples times the price of apples plus number of bags of oranges times the price of oranges. Now typically when students write this, they will write the variable second. So our equation would be 90 is equal to 5x plus 6y, with x equaling the number of bags of apples and y equaling the number of bags of oranges. So now we're going to utilize this equation in order to make predictions. So here we can see that our equation is 90 equals 5x plus 6y. And here we can see that we purchased 6 bags of apples. And remember, x is our number of apples. So what we're going to do is in x, we're going to replace x with 6 because we know that we bought exactly 6 bags of apples. And we're trying to figure out how many bags of oranges we can buy if we bought 6 bags of apples. So here we have 90 is equal to 5 times the 6 plus 6y. Well, I know that 5 times 6 is equal to 30. So then I subtract 30, so I have 60 is equal to 6y, divide both sides by 6, and I find that I have y is equal to 10 bags of, remember y is oranges. So essentially what I discovered is that if I buy 6 bags of apples, I can buy 10 bags of oranges.